Radical idea suggests gravity, and universe is an ocean full of information. In the summer of 2009, theoretical physicist Eric Verlinde had a brainwave that developed into a radical new idea about gravity, and the universe as an ocean of information. 10 years later, the last word about this has not yet been said. Spinoza laureate Eric Verlinde says he can understand that a lot of people had difficulty with the radical idea he proposed 10 years ago. Gravity is not the invisible pulling force of Newton, or the curved space-time of Einstein. Gravity arises due to the reallocation of information in the universe. Verlinde still realizes that it is a staggering idea that elicits an awful lot of questions. However, a lot has happened since then too, he says. Over the past 10 years, we have gradually learned a lot more about how you should talk about space and time information. I am seriously considering rewriting my story from 2009, but now formulated much more precisely. I think that could remove some of the skepticism that still exists. 10 years ago, however, the newspapers and media did not doubt it for a single moment. A brand new theory about gravity had been born. For the sake of convenience, Verlinde was called the new Einstein. In retrospect, he finds that awkward. That media hype sometimes gives rise to irritation among scientists, says theoretician Ko-Enruad Shalm from Leiden University looking back. The headlines were about a new theory of gravity that had been discovered, whereas Verlinde had a hypothesis that still had to be elaborated and tested. The media simply do not understand that nuance. All they want is the next Einstein, or Eddington on the front page. Just like researchers at many other universities, Shalm gave a colloquium in Leiden soon after the publication to subject Verlinde's paper to closer scientific scrutiny. A nice hypothesis, but still a long way off from a theory, was the down-to-earth assessment. Elaborate it and, in particular, come with observations and evidence. Justifiable skepticism, Shalm still thinks. But don't misunderstand me. It is incredibly difficult to have a really good idea in this discipline. So I have a lot of respect for Verlinde, because he has definitely given the field a new direction. In blogs and other public media there is sometimes harsh criticism of Verlinde's work. He is accused of just floating ideas for the sake of it, providing no testable predictions, publishing too little, only being taken seriously in the Netherlands, and scarcely publishing any subsequent articles. In all honesty, I follow that as little as possible, confesses Verlinde. He prefers to focus on specialists. People who all too easily say that I do not have a theory, clearly do not understand how theoretical physics works. You need to elaborate, and test a new idea step by step. We must find the correct formulations and techniques. He does, however, admit that he publishes relatively little. I have a certain preference for papers that constitute a significant step forward. Contrary to the skeptics' opinions, Verlinde's work is definitely taken seriously, says Shalm in Leiden. He has been cited more than 700 times. But it is very difficult material for which it is difficult to generate new results overnight. Verlinde feels that the idea that information is the deepest building block of the universe is gaining more ground. It is no longer as strange as it seemed 10 years ago. Perhaps as a result of so much ICT we are getting more used to the idea of information. However, the problem remains that the ideas in that area have only been properly elaborated for a universe that does not expand, and has an edge. For years now, I have been trying to persuade fellow theoreticians to take a better look at accelerating expanding universes without an edge, like ours. That has become a mission in itself. That would be a great idea, he thinks, even independent of his own gravitational theory. In 2009, and to the surprise of many, string theoretician Eric Verlinde derived Newton's law of gravity from the idea that the universe is an ocean full of information. The rules that apply in this are similar to the laws of thermodynamics for gases. In the gas world, it takes effort to blow up a balloon. In the same way, a weight opposes being lifted up because that requires the supply of extra information. That opposition was found to fully accord with Newton's formula, in which two masses attract each other with a force that is inversely proportional to the square of the distance. But unlike Newton, Verlin's theory also gives an idea as to where gravity comes from. It is an emergent force which arises from an interaction between fundamental units of information. Later, Einstein's equations for gravity could also be derived in the same manner. In addition, Verlin developed a version for an expanding universe in which a possible explanation also emerges for the extra gravitational force that keeps rotating galaxies together. Most physicists think that this arises due to dark matter, which is made up of as yet unknown particles.